Today you'll be learning lesson 9.4 on using factoring to solve those quadratic equations. Okay, remember in 9.3 we solved by graphing and by using square roots. Now we're going to solve by factoring, and that's a lot of what we worked on in that first part of chapter 8. Okay, so the first step is still the same. These have to be set equal to 0. Okay, then we're going to factor the equation, and remember these ones are the ones where you're going to have that middle term. Okay, if they don't have that middle term, then we use that square root method. Okay, but for these ones, you're either need to use the x method or the box method or the grouping method. Okay, remember that x method we can use when there's not a leading coefficient on our x squared, so it's a coefficient of 1. Or we use that box or grouping method when there is a number paired with that x squared. Okay, then what we do is we set each factor from our equation equal to 0, and we solve each of those factors for the variable. Okay, and where that comes from is the zero product property, which says for any real numbers a and b, if a times b equals 0, okay, then either that a or the b, or maybe even both terms, equals 0. Okay, so when we factor these quadratic equations, what happens is we end up with two sets of parentheses. Okay, looking at this example. So here I have x plus 3 times the quantity of x plus 2. So I know either that x plus 3 has to equal 0, or the x plus 2 has to equal 0, or maybe they both do. So to find the solutions for this, to find those values where it crosses the x-axis, I just need to solve for x. So the first one, I'm going to subtract 3 on both sides, getting me x equals -3. Okay, and the second one, I need to subtract 2 on both sides, getting me x equals -2. And once it's factored, solving these equations is that simple. Okay, the tricky part is still going to be that factoring that we worked on in chapter 8. Okay, so let's look at some of these that are already factored. Okay. So the first problem here says, what are the solutions of x plus 1 times the quantity of x minus 5? Okay, so since I know that zero product property, each one of those could be equal to 0. So I'm going to split them up into two separate problems, setting both of them equal to 0. And then I just need to solve. So x could be -1. Okay, well, here I need to add 5 to both sides, and x could be 5. So I know my solutions. So what this is saying is on that graph, I would have a dot here at -1, and over here at 5 for my parabola. I don't know where the rest of it is. By looking at this, I can tell there's no negative, so it's going to be going up. But I have no idea where the rest of that is, and it doesn't really matter as long as I know where it's crossing those. Okay? So here's some more. Okay, but these ones are a little trickier because now they have a coefficient, but my steps are still the same. Split them up, set them both equal to 0, so 2x plus 3 equals 0. Solve it, subtracting 3 on both sides, getting me 2x equals -3. Divide by 2, and x equals -1 and 1/2. Okay. For the other one, it's x minus 4. Set that equal to 0, so I add 4 on both sides, and I find out that x equals 4. So even though we got a fraction, remember that's okay. Okay, and I have my two solutions where that parabola would cross the x-axis. Okay, so pause the video and try this next one on your own. Okay. Once you're done, resume it and check your answers with mine. Okay, so I'm going to take that 7n squared, or not squared, sorry, 7n minus 2, and set it equal to 0, and the 5n minus 4, and set it equal to 0. So I'm solving those two problems. So I add 2 to both sides, and I get 7n equals 2, divide by 7, and n equals 2/7. And if you wrote it as a decimal, that's okay. Just make sure you don't round it. Okay, leave it exact, and that's why fractions are actually easier than those decimals. Okay, so for the second one, I need to add 4 to both sides, getting me 5n equals 4, divide by 5, and n equals 4/5. Okay, and if you think about that graphing method, that would be really hard to approximate those two answers. Okay, this is a 4 on the top. Okay, and that's why we need to know these other methods. So let's look at some that aren't already factored for us. So the first one we're going to look at is 5m squared minus, whoa, I cannot read apparently. Sorry, the first one we're going to look at is m squared minus 5m minus 14 equals 0. So my very first step today is to factor. Okay, and the first thing I'm going to look at is there a leading coefficient? Okay, there's nothing here, so I'm going to think about that x method. But before I even do that, I'm going to check if this is a perfect square trinomial. So looking at this last term, is it a perfect square? Negative 14? No, so I do need to use that box method. Remember, in the box method, the top box is the third term, what we need to multiply to get negative 14. And the bottom triangle, I shouldn't say box, is they need to add together to get a negative 5. Okay, remember, since that third term is negative, I need to have one positive and a negative. And since this second term is negative, my bigger number needs to be a negative. Okay, so thinking about 14, the easiest factors are 2 and 7. 7 is the bigger one, 2 is the smaller one. So if I have negative 7 times 2, okay, checking this process right here, negative 7 times a positive 2 is negative 14, which we want. And then if I check it the other way, negative 7 plus 5 is negative 5. So I've just found my factors. So my equation, instead of writing as a trinomial, becomes the quantity of m minus 7 times the quantity of m plus 2 equals 0. And now we're back to those same type of problems I just did. So what I do is I set each of these equal to 0, m minus 7 equals 0, and m plus 2 equals 0. Solve each of those equations. So here I add 7 to both sides. And I found out that one of my intercepts is 7, so that's a solution. And the other solution is m equals negative 2. So the two spots this would cross the x-axis is at 7 and negative 2. Okay. So this is another one just like that first one where you can use that x method. So if you want to practice that on your own, you should pause the video right now and then check through your work as I do mine. Okay. So first thing, no leading coefficient. So like I said, I need to use that x method. Okay. And then I'm going to look at that third term, negative 20. It's not a perfect square, so I do need to do this box. So I need to multiply to get negative 20, but add to get a positive 1 coming from that middle term. Okay, so thinking about 20, okay, 10 and 2 are the easiest. But if I add a negative and a positive, because my third term's negative again, so I need a negative and a positive. Okay, so if I have negative 10 plus 2, that's not going to get me a positive 1. So I need to think of other factors of 20 that are only 1 apart. Okay, and you should think of 4 and 5. Since that third term's negative, the 5 is going to be negative, and the 4 is going to be positive. So when I again check this problem, okay, negative 5 times a positive 4 is negative 20, like we want. And negative 5 plus 4 gives me a negative 1. So that actually means I screwed up because my number I got was negative 1 and it should be a positive 1. So what that means is I need to change my signs. So instead of this 5 being negative, okay, it should be the positive, and the 4 should be the negative. So hopefully if you were pausing this video and watching as I went through mine, hopefully you didn't erase it before we got here. Okay, so now when I check this, okay, positive 5 times negative 4 is still negative 20. But now when I have a positive 5 plus a negative 4, now I get that positive 1. Okay, so now I'm ready to write that equation as factors. So I have p plus 5 times the quantity of p minus 4 equals 0. And since I have that factored form, now I can solve it by setting each of those factors equal to 0. So p plus 5 equals 0, and p minus 4 equals 0. Solving both of those equations, subtract 5 on both sides. P equals negative 5. And the other one, add 4 on both sides. And I get p equals 4. So I have my two solutions to my equation, which remember on a graph would be the two spots where it crosses that x-axis. Okay, so let's look at some that are trickier because now these ones are going to have that leading coefficient. Okay, so when I look here, I no longer just have an a squared. Now I have a 2a squared minus 15a plus 18. Okay, so the first thing we should do is check if anything factors out. Okay, the only thing I can factor out of 2a squared is 2, but my middle term of 15 isn't divisible by 2, so I can't factor anything out, which means I'm going to need to make that box method. I'm actually going to move that over a little bit so I have some more room to work. Okay. Remember, you can also do this by the grouping method. I just prefer the box method, so that's the one I'm doing. So in the first square, I put the 2a squared. In the very last square, I put that positive 18. Okay. Now again, since it's 2a squared, I know the only factors of 2 are 1 and 2, so I'm going to have a 2a and a plain a. Okay. So then I need to think about my factors of 18, okay, and I know that I have 2 and 9, so maybe I try those, okay, and if I plug those in, 2 times a is 2a, and you need to remember that since this middle term's negative and the last one's positive, I should know these are both going to be negative, so I have a negative 2a, and if I plug in 9, here I have a negative 18a, okay, which if I combine those, I get a negative 20a, so that doesn't work, okay, so then I can switch those around and see if it works better that way. So instead of putting the 2 on the top, I put the 9 on the top, okay, and this is just me checking, guessing, okay, if it's going to work. So here I have a negative 9a, okay, and here I have a negative 4a. So when I combine those two, a negative 4a and a negative 9a, I only get a negative 13a. So since I've tried that 2 and 9 both ways, I need to pick different factors because those aren't working for me. Okay, so let's try some other factors of 18 are 3 and 6. Okay, so if I put a 3 up here and a 6 down here, let's see what happens. Here I get negative 3a, and down here I get a negative 12a. And when I combine those two, okay, negative 12 and negative 3 equals a negative 15a, which is what I wanted for my middle term. So I found my two factors. Okay, so yes, this method takes a little longer than the x method, okay, but that's because we have more numbers in our problem. Okay, so now I'm ready to write my equation using those two factors. So I have 2a minus 3 times the quantity of a minus 6, and it is set equal to 0. So to solve my equation, what I do is I take each of those factors and set them equal to 0. So I have 2a minus 3 equals 0, and a minus 6 equals 0. So to solve the first one, I need to get that a by itself, so I add 3 to both sides. So I have 2a equals 3, divide by 2, and I find out that one of my solutions is a equals 1 1/2. Okay, and even though it's improper, okay, so or since it's improper, you should always write this in simplest form, okay? To solve the second one, I add 6 to both sides, getting me a equals 6 for my second solution. So we have another one, but now if you notice this equation is not set equal to 0, okay? So the very first thing I should do is I need to move that negative 49 to the other side by adding it, okay? We can't combine it with anything because there'd be no like terms. So now I have x squared plus 14x plus 49 equals 0. Okay, and when I was writing that, I noticed something. That third term is 49, which is a perfect square. So I'm going to check if this is a perfect square trinomial. So if I square root 49, I get 7, and if I square root x squared, I get x, which means my middle term should be 2ab, which would be 2 times x times 7, which is 14x, which tells me this is a perfect square trinomial. So what my factors actually are x plus 7 quantity squared equals 0. Okay, that's my actual factored equation. And if you didn't notice that, okay, you could easily write that x method, because again, there's no leading coefficient. You'd have to multiply to get 49 up here, and add to get 14 here. Okay, and you would have found out that they were 7 and 7. Right? If you had to do that, perfectly fine. You're still going to get the same answer, because you'd have x plus 7 times x plus 7 equals 0. Okay? So when I solve my equation, okay, since I have a quantity squared, my very first step has to be to take the square root of both sides so I can get rid of that square. Okay, so when I do that, what I'm left with is just that x plus 7 equals 0. Okay, because the square root of 0 is 0, and when I take this square root, this radical sign, remember, cancels out that squared. Okay, so I just need to solve this equation. So I'm going to subtract 7 on both sides, and I get an answer of x equals negative 7. Okay, now some of you might be asking, why is there only one answer? Well, if you think about that, what this graph means is there's only one dot. 5, 6. I'm going to actually move my y-axis over here. 1, 2, 3, 4, 5, 6, 7. There's only a dot right here. So what that tells me about this function is that that vertex is actually on my x-axis. So there's that one. So here we only have one solution. So let's look at a little harder one. Okay, again, when I first look at this one, I should notice that it's not equal to 0. So my very first step is going to be to add 48x to both sides. Okay, So my actual equation is 16x squared plus 48x plus 36 equals 0, okay? And when I look at all those numbers, I was noticing that they're all even. Okay, so remember, if you have a leading coefficient, check if you can factor anything out, okay? So when I think about the numbers 16, 48, and 36, I know that my first step, or that all three of those numbers are divisible by 4. Okay, and if I factor out that 4, now I end up with a much smaller problem. I end up with 4x squared, because 4 times 4 is 16. Okay, 48 divided by 4 is 12, and the x is still there. And 36 divided by 4 is 9. Okay, now I'm not done factoring yet because I still have a trinomial inside those parentheses, so I can't just set it equal to 0 and solve, so I still have to factor that new problem, okay? But when I look at that, I already factored out, so now I'm going to check if they're perfect squares, okay? And when I check that, 4 is a perfect square, and x squared is a perfect square, so if I square root that, I get 2x, and 9 is a perfect square, so if I square root that, I get 3. And if I check my middle term, it should be 2ab, so 2 times 2x times 3, which is 4x, times 3, which is 12x. So I again have a perfect square trinomial. Just now, I have a 4 in front of it. Okay, so what I found is that my answer, or that my problem, is actually 2x plus 3 quantity squared equals 0. And again, for this one, if you made that box to factor this, you'd have ended up with the exact same answer. It just would have took you a little bit longer. Okay, so no matter if you notice this or not, the box will still get you to the same point. Okay, so now I'm ready again to solve my equation, because now I have something I can set equal to 0. Okay. In the last one, my very first step was to take the square root, but in this one, the very first thing I need to do is actually undo that multiplying by 4 by dividing both sides by 4. So now I have 2x plus 3 quantity squared equals 0, because 0 divided by 4 is 0. And now I'm ready to take that square root, because that squared part is all by itself. So I end up with 2x plus 3 equals 0, and I am ready to solve my equation. I'm going to subtract 3 on both sides, getting me 2x equals negative 3, divide by 2, and x equals a negative 1 1/2, which again means this is the x coordinate of my vertex for this problem. Okay. One more. That is a word problem. We haven't done many of those yet this chapter, so I want to go through one right here. Okay. You are constructing a frame for a rectangular photo shown. Okay. You want the frame to be the same width all the way around, and the total area of the frame of the photo will be 391 inches squared. Okay, what should the outer dimensions of the frame be? Okay, so they're asking, how long should this be? Okay, how long should this part right here be? And how long should this side down here be? They want the actual length and the width. Okay, well, what I know, and what hopefully you thought about, is that they're talking about area, and our area formula for a rectangle is length times width. Okay, they tell me they want the area to be 391. Okay, but the length and the width are the tricky part, because when I look at this picture, okay, I'm going to zoom in on it a little bit here so that you can see what I'm talking about. Okay, I know that the inside part of the length, okay, this down here in the green, is our length, okay? I know that the inside of that is 17, okay? But I have something out here and something out here because they want this whole length from end to end. And what they tell me is that that rectangle, or that little extra spot, has a value of x. So what I really have is an x plus a 17 plus an x for my length, okay? Which if I simplify that, I get a length, I can make it nice again, okay? I get a length of 2x plus 17, okay? Same thing when I look at the width. Remember, they want from here to here, and if I look at that picture, okay, they're telling me that this inside part, since I know it's the same as the other side, is 11, okay, but I have this extra space up here and this extra space down here, which is again the value of x. So for my width, what I actually have is 11 plus x, which if I write that in simplest form, okay, is 2x plus 11. Okay, now this one is really, really tricky because if you think back to when we talked about solving equations for quadratics, they have to be set equal to 0. And when I look at this problem, it's not set equal to 0. It's factored, but it's not equal to 0. So what I actually need to do is multiply these two factors together and then move that 391 so I have a trinomial that I can again look to see if it factors. Okay, so my first step is going to be to FOIL this problem over here. So 2x times 2x is 4x squared. 2x outside terms times 11 is a positive 22x. Inside terms, 17 times 2 is a positive 34x. In my last terms, 17 times 11 is 187. Okay, and this is still equal to 391. I didn't do anything with that yet. Okay, but if I just would have moved that, I couldn't have combined it with anything, and I would have had a really weird looking problem. Okay, so to solve, remember I have to combine these middle terms. Okay, so I really have 391 equals 4x squared plus 56x plus 187. Okay, but now I am ready to get it set equal to 0. So my first step is to subtract that 391 on both sides, getting me an actual quadratic equation of 0 equals 4x squared plus 56x minus 204. Okay, now this is a really tricky one because we have some really weird numbers, okay, but they have a leading coefficient, and if I notice, all of my numbers are positive, which means I know I can factor out a 2, but since I have a 4 for a leading coefficient, I should also check if I can factor out a 4, which does work for this problem. Okay, so when I factor out a 4, I actually get 0 equals 4 times x squared plus 14x minus 51. Okay, which is still equal to 0, but what that does for me is it gives me a much, much nicer problem to factor. And now when I factor this, okay, I have a leading coefficient of 1, so I'm going to use that x method. And that means I need to multiply to get a negative 51, and I need to add to get a positive 14. Okay, so I know my signs are going to be different because my third term's negative, but what I need to remember is that my bigger number is going to be positive because that middle term is positive. Okay, so when I look at this, 51, the only factor I think of right away is 17, which is 17 times 3. So if I put that bigger number here, since the middle one's positive, smaller one there, and let's check my work. 17 times negative 3 gives me negative 51, which is what I wanted. And 17 plus a negative 3 gives me 14, which is what I wanted. So now I'm ready to factor. So I have 0 equals 4 times x plus 17 times x minus 3. And now I'm again ready to solve this problem. Okay, now we can divide both sides by 4, okay, which still gets me 0 equals that x plus 17 and that x minus 3. Right? So if I solve this problem, okay, what I'm going to do, remember, is that each of those factors equal to 0. Okay? So I have x plus 17 equals 0 and x minus 3 equals 0. Okay? So when I solve this, if I subtract 17, I get x equals negative 17. And if I add 3, I end up with x equals 3. Okay? Now remember, in my problem, the x, if I can get it all back on here, okay, the x, I think I'll move it side by side, is actually the width of my picture frame. Okay? So what I actually have here is I know that these parts here are 3 inches wide. Okay, and that's what I found for x. Okay, and why do I pick the 3? Okay, x, so if I look here, these are all x's. Well, I should automatically exclude the negative 17, because can I ever have a width that's negative? No. Okay, there's never going to be a width that's negative. Okay. But when I actually finished the problem, okay, because I'm still not done, they asked me what the outer dimension should be. It's not 3. So what I need to do is I need to go back to my factors and plug in 3 for my x. So if we remember, screen is too small here. Okay, my two factors were 2x plus 17, okay, and 2x plus 11. They want the outer dimensions of the frame. So if I know that these are those, I'm going to plug in 3 and I'm going to solve. So I have 2 times 3 plus 17, which is 6 plus 17, which gives me one of my lengths of 23 inches. Okay, and the other factor was 2x plus 11. Okay. So I'm going to plug in 3, so 2 times 3 plus 11, whoops, oh, I can move like that, plus 11, which is 6 plus 11, which is 17 inches. So the outer dimensions of the frame are actually 23 by 17 inches, okay? Now that's a really, really tricky problem, okay? And you actually don't have one that hard, okay, that we won't do together. So if you struggle with anything like that one, make sure you ask for help if you get stuck, all right? And that's our third method for solving quadratics, okay? So the first method was graphing. The next one was solving square roots, which we use when we do not have a middle term. And this method today is factoring to solve quadratics, where we get those two groups and we set them both equal to 0 to find our two solutions.